Hello everyone, welcome to this video. In this video, we are going to learn two very important concepts. First, how to do slicing in Python lists, and second, how to reverse a Python list in place very optimally. So let's get started. We'll be solving this particular problem called as rotate array. So first, let's understand what this problem is telling us. So we have been given an integer array nums and we need to rotate the array to the right by k steps where k is non-negative. So what do we mean by this, right? Let's try to see the first example. So our first example is 1, 2, 3, 4, 5, 6, 7. Now let's say I rotate this array once towards the right. What I mean by that is all of my elements will move one place to the right. 5 will move to the right position, 6 will move to the right position, but you will see that there is no place for 7 to move, right? So what 7 will do, it will go ahead and move to the first. So you can think of it as like a wheel. You are rotating a wheel one step at a time, and one rotation will bring the last element to the first. So effectively, after two rotations, it will again be 6, 7, 1, 2, 3, 4, 5. And after three rotations, it will be 5, 6, 7, 1, 2, 3, and 4. Right? Now, let's make one very beautiful observation here. In this particular array, what if I tell you go ahead and rotate the array 7 times? So you will notice that on the fourth time it will become 4, 5, 6, 7, 1, 2, 3. On the fifth time it will become 3, 4, 5, 6, 7, 1, 2. On the sixth time it will become 2, 3, 4, 5, 6, 7, 1. And on the seventh time, you will see you will get back your original array again. Right? So this is what you get when you rotate a wheel as well. If you rotate a particular wheel 7 times, you will get the same wheel orientation again. From this particular observation, we understand that if we need to rotate the array k times, we can take a modulus of the given k with the length of the array. How do we get this intuition? Let's say our given array length is 7 and we need to rotate it by 7, right? So if we take a mod of 7 with 7, it will turn out to be 0. So basically we need to do 0 operations, which is correct. If let's say there are 14 given operations we need to do, it is effectively saying that you rotate the array 2 times completely, right? This will help us to bring the value of k in between 0 to n-1 always, because the modulus of k mod n will always lie between 0 to n-1. Okay, so this is the first observation that we make. Now secondly, let's think about how can we implement the solution itself. So given our first example, our first option is to pop out the last element always. So let's say I pop out the last element 7 and then make a new list of all the other n-1 elements here and append it to our new list, which is 7. Right? So this involves making a new list every time. Right? So you will do this 3 times. You will do it once, you will do it twice, you will do it k times. Every time you are popping out the last particular element and inserting in the first place. Now let's talk about what is the time complexity of this solution. right? If you notice, you are doing an order n operation for k times, which is not very optimal. And the space complexity here is also order of nk, because at every kth step, we are making a new array of order n size. And you can see that in a given problem, we can have n up to 10 to the power 5 and k can also be up to 10 to the power 5. Now, if you estimate how much operations you are doing, this is n into k, which is 10 to the power 5 into 10 to the power 5, which is 10 to the power 10. Now, I'll teach you guys one thing. If you do around 5 to the power 5 into 10 to the power 7 operations, it takes the computer around 1 second, which will pass in our time limit, given time limit. But if you are doing 10 to the power 10 operations, it will take around 10 to the power 3 seconds, which is huge. It's like 1000 seconds. So if you implement this solution, Leetcode will say time limit exceeded. You need to do better. Let's think, how can we do this better? Going back again to our particular question, you can actually see that if we rotate the array 3 times, you are seeing that these 3 elements which are there on the last, these are getting swapped with the first 4 elements which are in the start. So in the final array, 5, 6, 7 will be transferred to the first 3 elements and 1, 2, 3, 4 will be transferred to the last k elements. We do an observation here is last k elements become our first k and the first n minus k elements become our last n minus k elements. And we can implement this very, very optimally using a concept called Python list slicing. So let's go ahead and learn that particular concept. Let's say you are given a Python list 1, 2, 3, 4, 5. Now what Python gives you is that you can obtain the slices of this particular list very optimally. What you can do is that you take A and you can mention a start index, you can mention end index, and then you can mention a step. Let's go and understand what do we mean by all of this. So this is basically saying, Python, go to this particular start index. Let's say we mention, and we know that indexes are done in zero, in like a zero order. So it starts with 0. Now let's say we go ahead and tell Python, start my index with 0, end it at 3, and make the step to be 1. What I'm telling Python is that give me a slice of my particular list which starts at this particular element 1, which is at 0th index, include 1, include index 2, but don't include this index 3. This one, the start index is inclusive. Basically, you want to include this in your answer, but this stop index is exclusive. So you basically say that you want all the elements just before this particular index here. And this is our step size. This is basically telling how many elements do you want to skip before getting to the next one. So 1 means you don't want to skip anything. If you mention here 2, you are taking 2 steps. Starting from 1, you go ahead 2 steps. So you will skip the middle element, which is 2 here in this case. So this helps us to get slices of a particular list very, very fast and very, very easily itself. Let's say we want to get the first k elements. We can just mention Python, start with 0 and end with k. right? So this will give us the first k elements to us. Now, one more important concept for us to learn is negative indexes. How does Python handle it? Two ways Python indexes all of our elements. First is using a positive index, right? As we all know that it starts with 0, 1, 2, 3, 4, 5. But Python also does one more thing, which is very, very helpful for us. It also does a negative indexing. 6 will have an index of -1, -2, -3, -4, -5, and -6. What this is telling us is telling Python this is the -1 element, this is the -2 element, -3 element, -4 element, -5 element, -6 element. So let's say you want to get the last two elements of your Python list very quickly. You can just simply mention the start index, which is -2, and you want to go till end. If you want to go till end, you can either not mention anything, or you can go ahead and just mention the value of like a total length. In our case, total length is 6. After learning this concept, let's see how we can solve this particular problem. So we need to get the first k elements. What is the value of the first k elements? It is equal to the last k elements on rotation, and then the value of the last n minus k elements is equal to value of first n minus k elements. So this is what we need to implement. Let's say we have all of these elements, right? And before this, one more also important thing in Python is how do you swap between elements? This is something that only exists in Python. Okay, so let's say you want to swap these two elements, a equal to 4 and b equal to 6. What you can do is that you can introduce a new element c, we will store the value of b, right? What you can say is that the value of b is a, and then my value of a is c. Because the value of b has already been lost, that's why we need to store in another third variable c. But in Python, how you can do this, you can just simply say and state this particular line. So this, how this works in Python, Python starts to compute the value from the right hand side. So first we will compute the value of b and compute the value of a, and then Python will assign value b to our variable a, and then value of a to this particular variable b. So essentially, we can swap two particular variables using just one line in Python, and that is pretty awesome. We will use the same technique here to do this thing. So basically, when we are swapping first k elements with the last k elements and last n minus k elements with the first n minus k elements, how we can do this? We can basically write our first k elements should be equal to my last k elements. I can safely write this, right? And then all the elements which is after k, they have to be equal with all my elements between 0 and minus k. So with this one line, we are doing an in-place replacement of these two cohorts of k and n minus k elements. Let's try to go ahead and code this up. We can write here first n is the length of our particular nums list, and then we can do a modulus we'll do a modulus of k with our n as we learned, and finally we need to do some operations. If my k is not equal to 0, then I can say my nums of 0k comma nums of k equals to nums of minus k, basically the last k elements, and then nums of 0 comma minus k. And finally, we don't need to return anything because we have done the replacement in place. Do not return anything and modify nums in place. Let's try to run this and see if it actually works or not. And you can see that this solution works. Now, the time complexity of our particular solution was order n. We are just making these two lists, right? And our space complexity is also order of n. Can we reduce the space complexity, right? Now, if you'll see, there is one more pattern that we can observe in this particular problem. So when we are rotating the array, can I say that first we are bringing kind of the last elements to the first, and we are taking the first elements to the last of this particular array. So if we first reverse the entire array, it will become 7, 6, 5, 4, 3, 2, 1. Now notice that we needed to rotate 3 elements, right? Now if we just do a reversal of these first 3 elements and a reversal of the last n minus k elements, we will get our answer, right? So first reverse the entire array, then again go ahead and reverse the first k elements, which is 5, 6, 7, and then also reverse the last n minus k elements, which is 1, 2, 3, and 4. What is the beauty of this solution? We are not using any extra space here. So our space complexity becomes order of 1. So we have reduced the space complexity from order of n to order of 1 just by observing this particular pattern in our test cases. And you will be able to observe these patterns only and when you practice a lot. You write down all of these particular test cases by your hand itself. Then only you will see that this pattern is emerging, right? So let's try to go ahead and code this up. We will make a reverse function which is taking input L and R, and then while my L is less than R, I will do a reversal. So I will do a reversal of nums of L to nums of R equals to 2. So this is the swapping technique that I talked about. It will be nums of R, common nums of L. And then we go ahead and increase L by 1 and decrease R by 1. So given any particular segment, this will go ahead and reverse my nums array. So what is the first thing that I want to do? I want to reverse my entire array first. So 0, n minus 1. Now in the second step, I want to reverse my first k elements. So 0 to k minus 1. And after in the last, I want to reverse my last n minus k elements, so which is k to n minus 1, right? So this is the 3 steps that we talked about. And let's try to run this solution and hopefully this should work. And yes, if you see that this solution has worked and we have successfully written a solution which is order of n in space and order of n in time and order of 1 in space. So in this video, you learned how to do slicing of our Python lists and how to reverse a Python list in order of 1. Thanks for watching this video. See you in the next one and keep coding.